for the folks at home, and so you guys pay attention as well. A lot of things you're going to do are going to be covered in this as well. Cool? All right, don't need to write anything down. Most of it will be with you, and I'll leave it up on the board as well. Okay? So for this unit, we're talking about kinetic energy and potential energy, energy in general. Okay? Energy is kind of the opposite of matter. What is matter? It's like first day of class in here. What does matter? It can be solid, liquid, gas, or plasma.
Anything that moves.
Doesn't have to move. Okay. Matter's everything, right? Matter's stuff. Matter's stuff. If it's something, it's matter. Energy is what makes matter move. Okay. And so remember, in chemistry class, we talked about which matter is moving. What matter is moving? All matter is moving when? All the time. Even the matter that's sitting here standing still, what is it doing? Not necessarily very slowly. It's vibrating. Okay, and liquids are flowing and gases are moving all over the place. Matter is always moving. Now, what we're going to do is we're going to take that concept of energy. Okay, Shimon, come down, man. We're going to take that concept of energy and we're going to make it macroscopic. Usually in chemistry class, we're talking about microscopic energy. We're talking about vibrating particles and things like that. Today, we're going to look at energy, and we're going to look at energy in a macroscopic way. What is the difference between macroscopic and microscopic?
It's small.
Yeah. What is macroscopic?
Big.
Yeah, you can see it. Okay, so all of the energy we're going to talk about today is specifically talking about the energy of macroscopic motion. Energy of motion you're going to be able to see. Okay, so first thing we need to understand is velocity. Okay, what is velocity? We've talked about it before. Speed, and it has to do with, specifically, velocity is speed in a certain direction. So if you're going in a circle, your velocity is constantly changing because you're constantly changing your direction. So velocity is going to be straight line speed. Okay, how are we going to calculate velocity? If I want to know how fast something's going, I take two measurements and then divide. What two measurements? Volume doesn't have anything to do with velocity. Think about it. You're running a race. What are the two things you want to know to run the race? Your time and your speed. Speed and velocity is kind of the same thing. Go ahead. What do you mean by meters?
How far you run?
Yeah. If you know your distance and you know how fast you ran that distance, then you know your velocity. Velocity is distance divided by time. That's why if you're on the highway, and you want to know how fast you're going, what do you say?
Miles per hour.
Miles per hour. Miles per hour. Okay? No, you see what I'm saying? Miles is a distance. Hour is a time. Make sense? So you need to know your distance and you need to know your time. Now, two other formulas we're going to need to know and understand are specifically looking at our types of energy. Okay? We've got potential energy and we have kinetic energy. Potential energy. What is a potential? Potential energy. Energy that's happening or energy that could happen? Very good. Okay? The way I always think about potential energy and kinetic energy is the rock and the hill. Where is the rock on the hill that has potential energy? Very good. And what is it doing? Sitting. It has the potential to move. Very good. Very good. Now, in chemistry class, potential energy is the energy stored in between the atoms. What do we call that? In between the atoms? What's holding your atoms together? Well, molecule is what you call the whole thing. But what's in between the atoms holding it together? Covalent, ionic, metallic. Bonds. Very good. Okay, now everything in chemistry class has potential energy because you can break those bonds and release energy.
Does water have potential energy?
Absolutely. Water has potential energy. If you mix some salt, some sodium in there, not salt, sodium, the water can do what? We talked about it right at the beginning of the year. It can explode. It breaks apart, that sodium breaks apart those bonds and it releases that energy. So yes, water absolutely has potential energy. Absolutely. Okay. We don't have any, but you could. Okay. You can't, but good luck with that. All right. All right, stick with us now, guys. So, but what we're talking about today is not necessarily chemistry potential energy. We're going to be talking about macroscopic movement potential energy. Okay. So now, why does the rock on the top of the hill have potential energy?
Because it can fall.
There's 3 reasons it has potential energy. What do you say? Okay, but the potential energy has nothing to do with whether or not you push it. The potential energy is there even before it moves. Because it's heavy, it has weight, it has mass. Excellent. Okay. All right. 2 more reasons. Very good. It's at the top of the mountain. So it has what? What do you have at the top of the mountain that you don't have at the bottom of the mountain? Well, we'll go ahead and say that. Sure. We have potential energy on Earth because we have gravity. Okay. All right. And then one more thing. What do you have at the top of the mountain? There's gravity at the top of the mountain and the bottom of the mountain. So you didn't really answer my question. You kind of skipped it. Okay. What do you have at the top of the mountain that you don't have at the bottom of the mountain? Wind doesn't really have anything to do with potential energy. I buy it though. Well, what are you gaining when you go to the top of the mountain?
Momentum.
You gain speed on the top of the mountain versus the bottom of the mountain? Guys, use your common sense. What do you have on the top of the mountain that you don't have on the bottom of the mountain? What do you gain? Momentum. What do you mean? Tell me what you mean. I'm confused. No, it's not complicated. You guys are making it complicated. When you go to the top of the mountain, you're gaining what? Not a phone call. Just cut that off. Come on. Just close it. Just do this. Come on, Cameron.
I didn't mean to do that.
I know. Close it for me.
Oh.
All right. Guys, at the bottom of the mountain, you don't have it. At the top of the mountain, you do. What do you gain?
What? Speed.
I'm late, on the edge of my seat explaining how do you gain, how are you faster at the top of the mountain than you are at the bottom of the
I'm
mountain?
already down.
Never even know. Temperature.
All right, when you're next to the ocean, you don't got it. When you're on top of the mountain, you got it.
You got it.
What?
Friction?
Mass.
We already said that.
Oh, we already said that.
Okay, let me make it simpler. On the bottom of the ladder, you don't have it. On the top of the ladder, you do have it.
Force.
I'm not going to give this to you guys. This is way too
What do
easy.
you mean on the top of the ladder and the bottom of the ladder? You don't
What's different about you on the top of the ladder than on the bottom of the ladder?
You up. You up.
Say it loud. What do you gain, Tamara? Height.
Oh,
Lord of mercy. God, oh. All right.
Wasn't that simple?
How's that not simple?
No, because you said at the ocean you die, and the mountain you don't.
I definitely did not say die.
Well, what did you say there?
He said the ocean.
At the ocean, what is your height? 0. On top of the mountain, what is your height? However tall the mountain is, right? Okay. Potential energy is concerned with mass, gravity, and height. Okay. So on Earth, which of these 3 will always be the same? Only one of them will always be the same on Earth. Gravity. Okay, no, mass will not be the same. Some of us are different than others. Does that make sense?
Yeah,
But gravity will always be the same.
Well, that went great.
Gravity will always be the same as long as you're on Earth. Remember we talked about constants before? Gravity will always be 9.8. Come on, guys. Come on, give it to me. I know it's Tuesday morning. We're just starting, but stick with me. Gravity is always going to be the same as long as you're on Earth. Whether you're close to Earth or not, The acceleration due to gravity is 9.8 meters per second squared, which means each second you increase your speed by 9.8 meters per second. Okay, so you go faster and faster and faster as you approach Earth. This is the acceleration due to gravity that every one of us is feeling all the time. Okay, so these two things can change. So who's going to have more potential energy? Someone who weighs 250 pounds or someone who weighs 100 pounds?
250 pounds.
The person with 250 pounds is going to have more potential energy because they have more mass. Okay? Who's going to have more potential energy? The person on the top of the ladder or the person on the bottom of the ladder?
On the bottom.
Why?
Top.
On the bottom.
Why? Explain yourself, Cameron.
Because all your weight is down.
Okay?
What?
So what is, no, stick with us. So this number on the top of the ladder will be higher or lower?
Lower.
Well, no, I'm listening to Cameron's logic here. Let's go. Okay, stick with us. So you have less height on the top of the ladder.
Yes.
Explain.
No. What I'm saying is, I felt like you're lower, like the lower you are, the more weight you would have. That's why I said what I said.
Why?
Because all your weight is on the ground.
And if your weight is in the air, you have less weight.
No.
No. Don't give up. Explain yourself. Don't just say something and go let it poof. Explain yourself.
Because, like, when you're down, all your force is on the ground, right?
Okay, gotcha.
Okay. When you're in the air.
Okay, I'm listening.
When you're in the air, all your weight is like it's just floating. You know?
So I weigh less now.
Yes.
That's amazing.
What?
I weigh less here than I did on the ground.
Yes.
I'd love for you to explain that to me.
We're the same thing.
Watch your mouth. You with me?
I guess.
Okay. So where are you going to have more potential energy? The person on top of the stool or the person standing on the ground?
I guess on the top.
Because you have more room to do what? You have more room to do what? If you're on top of the stool.
Float.
Okay. Wait. Time out. Let's pause. Who is floating?
You know what? I'm gonna get my home go to sleep.
You have more room to do what on top of the ladder, on top of the mountain, or on top of the stool?
Move. Yeah, more room.
What could, you guys said it. As soon as I got on the stool, what did you say? Because I might?
Fall.
You have more room to fall. So you're going to have more potential energy. So the more you weigh and the higher you are, the more potential energy you have. Now, how can I change this? As long as what? I can't change gravity as long as you don't change what? I got it. Okay. I just said it, guys. Gravity is always the same as long as you what? As long as you stay on Earth. Okay, Cameron, lunch?
No.
Jamar? Jordan?
4.
4, buddy. Thank you. Have a great day. All right, guys. So potential energy, gravity. How can I change gravity? We just said it.
As long as you're not in
Look, go to a different planet. Gravity's going to be less where?
water.
A little bit. A lot less on the moon. Jupiter gravity's going to be way more because Jupiter is what? Way bigger. Very good. Okay. All right. So, but we're not changing. We're not leaving Earth, so gravity will always be this. Now, somebody's going to start this lab in just a second. They're going to be like, what do I use for gravity? Y'all with me? Okay. All right. So now, what have we not done yet? We talked about potential energy. We talked about how to measure velocity, but we haven't actually moved yet. So we need to move. So instead of potential energy, what's my formula? What are we going to use? What do you call the energy of motion or movement? Kinetic energy. Very good. Okay. Kinetic energy. Okay. First off, it's going to be a little bit more complicated than just multiplying 3 things. So first thing we need to do is we need to multiply times 1/2. Why that is, you'd have to ask somebody smarter than me. Okay. But there's 2 things that give you kinetic energy. One's easy, it's already on the board. We just said it's the energy of motion. What's on the, well, your distance divided by your time, which means your velocity, okay? So we have some velocity. And we're actually going to square the velocity. Okay? Because it means more than the other thing. What else means you have more kinetic energy? Who has, what do you say?
Gravity.
Gravity is the potential energy.
That
Very good. Why?
because
It determines how fast.
Nah.
just like it shows that that you weigh more.
Okay, so we want to throw Dylan so that he goes 50 miles an hour. Okay, okay, y'all stick with me. And I want to move a car so that it goes 50 miles an hour. Okay, which takes more energy? The car. Okay, because the car is way heavier. It wouldn't take anywhere. It wouldn't take, and that releases, and by pressing the gas down, you're releasing a whole lot of
But it's
energy.
gonna take a minute to lift somebody up and throw them 50 miles per hour. I mean,
If you could create an explosion that's the same as the explosion in your engine, Dylan will be going way faster than the car.
but you gotta pick them up and lift them first, right?
Not the explosion can pick him up and lift him.
Yeah, you just put a big airbag on the bike.
Okay. How you gonna pick up and lift the car to get it going?
No, you gonna get in the car, crank it up.
And what do you do when you crank it up? What's happening?
Put it in reverse.
No. What's happening in the engine?
It's making noise like it's creating energy.
Explosions. Explosions are happening over and over again. Cameron, stick with me. What do you put in your car to make it go?
I mean, gas.
Gas. And gas, why do we use gas instead of water? Because gas explodes. So what you're doing when you move a car, I got you, Cameron. What you do when you move a car is you're creating a whole bunch of little explosions. Go ahead, Cameron.
Oh, okay. So, not trying to be off topic, but we're talking about gas, right?
I'm listening.
So, what we gonna do if we run out of gas?
Okay, it's bull crap. Don't listen to it. Be patient. Everybody was filling up their gas this morning. It's no big deal.
I know. I was trying to do the last time. Huh? Yeah, they used it. So it's gonna come back.
It already is.
Oh, it is?
It's Facebook craziness. Pay no attention to it.
Oh,
Just like toilet paper last year.
okay. Boy, I ain't stop. No,
Nobody ever actually ran out. Let's be honest.
shit, I had some napkins in the
And
kitchen.
you're ready. All right, so there's your 3 formulas for today. The only thing you have to remember, this extra here, is this guy right here will always be what? Which is what? Very good. All right, so for my folks at home, these are your formulas to use. Enjoy. If you have any questions, shoot me a message or join our Zoom.